All right, let's talk about changing scales and scale drawings. Okay, the playground to the right is depicted by a scale where 1 centimeter equals 30 meters. Note, each grid square is 1 meter by 1 centimeter. If we change our scale to 1 centimeter now equals 20 meters, then how would it compare to the drawing on the right? So we want to know what happens to our drawings when we change our scales. Does it get bigger? Does it get smaller? And so we got to look at the ways that we can kind of solve something like that. And sometimes it can be very confusing, which is one of the reasons to go over it. Because sometimes people think that because, we're going, 1 centimeter equals 20 meters, that maybe we're getting smaller. When in actuality, we're actually going to be covering more area, which you'll see as we go through this. So if I go to my next slide here. Well, let's talk about that. Sometimes, like I said, there's a perception that the shape will get small when actually it is quite the opposite. So here's our original drawing here. 1 centimeter equals 30 meters. And we saw it, 3. Well, realize that what we have here, right, is 30, 30, and 30. Well, if a centimeter is now worth 20, like we have over here, then guess what? We have 20, and then another 20, another 20 to get up to 60. And so you just get 4 of them right here just to get to 80. So right now we're up to 80. And so then we look at here, and then right here would be that 90. Because it'd be 10 here, right? So 20, 20, 20, 10. So you realize what happens here when we change that scale. We're getting a little bit bigger here. So pay attention to that. So let's talk about this a little bit more here. Let me get out back the pointer. Go to the next slide. All right. Let me do some erasing here. All right. So with a scale of 1 to 30 centimeters, we'll talk about the mathematics now. Numbers. If we look at this, right, with a scale of 1 centimeter is 30 meters, we only need 3 centimeters to represent 90 meters. 4 centimeters to represent the 120, and then of course 2 for 60, and 5 for 150. But as you'll see on the next slide, we now need the 4.5 centimeters to represent 90. And so with that next slide here, and again, 4.5, like I said before. And we need the 3 here, from 2 to 3. And so what we're seeing here is that the scale has become 1 to 1.5. With that original scale of 1 centimeter, 30 meters. But when we go to 1 centimeter equals 20 meters, then we're scaling it. So the drawing has been scaled 1.5. Because you just have to realize, okay, so we have, we went from 3 to 4.5. 3 times 1.5 is 4.5. If we go right here, 2 times 1.5 is 3. If we go, what the original was the 4 times 1.5, gets 6. And so you see how it's playing out here. You close the part here so you can see read everything down there when my thing pops out of the screen there. Think about the playground image. With larger drawing, you can see more details because of the larger area being used on the paper. So the area is actually even greater because remember, 1.5 squared is 2.25. Remember, when we talk about area, it's always going to be the square of the scale. All right, let's go to the last page here. Last slide. Oh, that was the last slide. All right, so let's talk about bearing some of these things in mind here. So key thing to always remember here is that with your area, we figure out your scale. If you square that scale, that's how much greater the area is going to be. All right, out here.